my atom, right? So I'm going to go back to nitrogen. Go ahead, sorry. We go back to nitrogen, right? Nitrogen tells me 007, James Bond of elements, right?
Yep.
We got my atomic number, we got the atomic mass, that tells me my protons, neutrons, and electrons. Protons come from the atomic number, always. So my atomic number of protons is
7.
7. My number of neutrons, I can figure that out because it's atomic mass
7.
minus the number of protons gives me the number of neutrons. That tells me if I substitute numbers in, I have 14 minus 7 gives me 7. Number of electrons. Why do I have, or how many electrons do I have?
7 because the protons.
7 because of the protons. Why 7 because of the protons?
Because protons, electrons are opposite charges.
Protons and electrons need to equal it out because a proton carries a positive charge and an electron carries a negative charge. All of that's review, right? I'm going to review drawing it out as well. So I draw out my double donut. Donut. What's that centerpiece called?
The whole.
Nucleus, right? We call it the nucleus. What's contained or housed inside of the nucleus?
The protons and the neutrons.
Protons and neutrons. Thank you, JJ. I heard you. What goes round the outside? Round the outside.
Electrons.
My electrons go floating around the outside. And that's what we're going to focus on today. But I want to make sure we all understand where we're coming from and where they come from. So all I do now is just transfer the numbers that I've already found for my atom into my drawing. So I have my protons, number 7. Neutrons, number 7. Electrons, number 7. But here's where I want to focus at. And here's what I like to talk about. So, it is 1 o'clock in the afternoon. Where am I most likely to find you? 1 o'clock in the afternoon. Where am I most likely to find you? What'd you say? Upstairs? You say cafeteria? At 1 o'clock? What time is it right now? 1:30. Is it 1:30? Oh, dude, I get my times messed up then. I apologize. It's 1:35. Where am I most likely to find you? In this class. Does that mean every day, every time you're going to be here?
No, sir.
No. Where could you possibly be at 1:35?
Here.
Sleeping.
Home, the doctor.
You could be at home. You could be at the doctor's.
In the bathroom?
Fishing? Sure. In the bathroom. Could I have taken you to the library so we could have moved our class to the library? Could we have gone to a computer lab and taken our class to the computer lab?
Yes.
So you might be scratching your head and say, well, what's the point of that? 95% of the time, where can somebody find you if they need to find you at 1:35? In this room, right?
Yep.
So electrons have an address. They have a house. They can most likely be found in certain locations. There are energy levels that actually go around the outside of our atom. So I'm going to draw out a nucleus here, and then I'm going to draw dotted lines to represent what are called energy levels. Energy levels are the addresses of the electrons. For those who've had chemistry or ICP, do you have a different definition for that? Did your teacher give you anything else that would sound different than a address or a position? Is this new information to you? Is this new information to anybody? So there are energy levels. Does anybody know how many total energy levels there are? 7. I said 7, you say 8. Go to your periodic table real quick. Wherever it's at, pull up a picture of the periodic table. How many horizontal rows are there on the periodic table?
9.
Okay, horizontal row. Horizontal means left to right. Horizontal is flat. You have 9. Okay, when I say 9, take a look at the bottom 2. Doesn't it have an arrow that shows that it actually gets shoved up inside of 2 of those rows?
Yes, sir.
So now let's recount putting those back into that. You have 7 total rows. How many energy levels do we have? 7. How many rows are there on the periodic table?
7.
Coincidence?
I think no.
There's 7 rows. There's 7 energy levels, right? So I don't know if I drew all 7. So I have energy level 1, 2, 3, 4, 5. And I'm not going to draw all of 7. That's 6. That's 6. And I'm not going to draw all of 7 because I'm lazy. So 1, 2, 3, 4, 5, 6, 7. What do you notice about, even though on my drawings, what do you notice about each one of those rows or each one of those energy levels? They get bigger as they move out. How many elements are on the periodic table in that first horizontal row?
2.
2. Maybe there's a coincidence there. How many elements can fit, or how many electrons, not elements, how many electrons can we maximally fit in the first energy level?
2.
2.
Whoa.
Max 2. Wait a minute. How many elements are on the first row?
2.
2. How many electrons can we fit in the first energy level?
2.
Brittany, how many electrons can fit in the first energy level?
2.
How many elements are on that first row? Okay. Coincidence? 2 in the first row, 2 in the first energy level. What's my max number for my second energy level?
8.
What's the max number, do you think, for the second energy level?
8.
Logan, what do you think?
8.
Why?
Because that's the amount of elements.
There's 8 elements in the second row? I'm just saying it that way. I'm not like questioning you. There's 8 elements in the second row, right? Aren't there?
Yes.
Did you count them?
Yes, I did.
How many elements are in the second row, sir?
Isn't the one at the bottom get pushed up so that
Not into the second. They get pushed up in like 5 and 6. Look at where the arrows are at.
so it would push the other 2 up?
No. No, because look at the numbers. So if you look at the numbers, the question was, doesn't it push all the rest of them up when they get shoved back in? No, because if you look at, I can't even look at it. Is it barium? What's the 1, 2, 3, 4, 5? What's the element number of cesium? What's the atomic number of cesium?
58.
58. Then look down at the bottom row in the lanthanide series. What's the next number in the first number in the lanthanide series? 57, right? So if I go back up, next to cesium you have barium, and then next to barium, it goes from 56, the next one over is 71, right? Are you seeing that? So what they've done is just remove that series out because they don't fit with other properties. But when we're talking about them, we can throw them back in right now. What's my max number? In the second row, I have 8 elements. Sorry. What's my max number in the second energy level?
8.
8. 8 elements, 8 electrons. 8 elements, 8 electrons. Coincidence?
No.
Now, what's my next one? This one's where it gets tricky. And this one doesn't follow my rules. My third energy level.
12 or 16.
It actually does. I think it's 16. If it's not 16, it's 18. The max is like 18 or 16. I think it's 18. However, for my class and my purposes, we will not care about elements and rows, energy levels 4 through 7. The reason why is 98% of Earth's minerals and elements and rocks are all made up of elements that are found in the first 3 rows of that periodic chart. So the way that I talk about the elements, it has 2 in the first energy level, 2 in the second energy level, 2 in the first, 8 in the second, and 8 in the third. 8 is my magic number. Right?
Yes.
So using this information, I'm going to redraw nitrogen. Right? Do You guys know how to do this? Anybody know what I'm doing and know where I'm going with this? So I'm going to redraw nitrogen. How am I going to redraw nitrogen? Well,
Yeah.
my nucleus is going to stay the same, right? Did I change anything about my nucleus?
No.
Nope. So I have 7 protons and 7 neutrons. What did I change?
The electrons.
The electrons and where they're located.
Number 2.
Huh?
Number 5. 2 and 5.
They're found outside the nucleus in energy levels. How many electrons fit in the first energy level?
A 2.
A 2. Can I fill up my energy level?
Yes.
Because how many electrons do I need to put into nitrogen?
7.
I need to put in 7. Matt, will 7 fit in the first energy level? No, but how many will? 2. I put 2 electrons in my first energy level. Some of you get taught to draw it as dots. Anybody get taught to draw it as dots? I'm lazy, I don't like dots, and it gets confusing sometimes because I make mistakes when I write dots. So I'm just going to write the number 2. So I have 2 electrons. Am I done drawing my atom?
Not yet, sir.
Why not?
Because you have to make the other energy level.
I need to make a second energy level. Why do I need to make a second energy level?
To get the rest of your electrons on the atom.
Because I still have how many electrons, Michael? I still got 5 left. JJ, how many can fit in the second energy level? 5 can. How many total can fit though? 8. So can I put all 5 in there?
Of course.
So if I put all 5 of my electrons in, I have 5 plus 2. How many total electrons? Is that complete? Have I completed my nitrogen?
Yes, you have.
One more word that I want to make sure we understand is this one right here. This is what's called a valence electron. What do I mean by a valence electron? Outermost. Furthest away. Why are they important? Because the number of valence electrons controls how you bond. Why is that important? Because to make this rock and make this rock, different atoms bonded together to make different products. There is a distinct difference between these 2 rocks, right?
Yes.
They're both made of atoms, and they're both made of atoms that chemically combine together and bond. The type of bonding is controlled by the number of valence electrons. So the atoms that make this up and the type of valence electrons it has is different from the types of rock minerals and the types of elements that make up this rock. So understanding the whole point of knowing this chemistry is so we can figure out what's actually going on here when we start to look at the differences in rocks and minerals. So, what I would like for you to do is to take ones that we've already done, like silicone, oxygen, krypton. Actually, krypton doesn't work. Because it doesn't follow my rules, so I believe it's below. Where is it in the first 2 rows?
Oh, yeah, that's right.
We can do neon. We'll do neon. And then I want you to do lithium. So draw those 4 out with the correct energy levels. When you're done, raise your hand. I'll come around and check them. We'll put them up on the board.
No.